Yo, what's up, guys? Welcome back, day 63. Yesterday I kind of messed up. We actually did Pokemon 63. I thought yesterday was 63, so we're gonna do 62, the Pokemon Sound 62 today, and then we'll go back to normal tomorrow for day 64. Just a little heads up, I'm gonna be away on Saturday, so yeah, there'll probably be no video. There might be no video tomorrow, but I think I will make a quick video tomorrow, but it'll probably be a shorter one. You know, tops an hour. But there'll be no video Saturday. I'm going out of town with my girlfriend somewhere, so it should be pretty fun. No video Sunday, because I'll be with her still. And then we'll most likely do a video on Monday. Monday evening, probably. So... yeah, excited. Should be a fun weekend, and you know, fun times ahead, hopefully. So yeah, let's get to our Pokemon of the day. We have a Poliwrath. Let's take a listen to this sound, shall we? Okay, maybe we can get something a little better than that. Oh man, jeez. Look. Guess this is the only sound we got. Poliwrath on. Do-do-do. 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 There's our sound. Cool sound. But yeah. Let's take a look. Let's take a look at our problem of the day really quick. Maybe it's a chill problem. Ooh, we got an easy. Let's start with that. Seems like pretty high acceptance rate. Then we'll get our powerful study program up in here. Okay, you're giving it a 0 index. My sister's calling me, man. Okay, I'll be back. I'll answer this call, and then, yeah, we'll keep going. Alright, we're back. Let's continue with this question. Yeah, so I'm kind of thinking here. So, we have to find the repeated value within this list. So here in this list, we got 2. 2 here. It's because 2 is repeated. And then we're missing 1, 2, 3, 4. Because we have 4 numbers. We're missing 4, right? Here we're missing 9. Oh, sorry, we got our repeated number, which is 9, because we got 2 9s, and then we're looking for a 5, and that's our missing number because we go from 1 to 9. We were given a 0 index 2D integer. Okay, so I think first we have to get the length. Length is equal to the length of maybe would the best way be to flatten this array? Do we flatten it? I don't know. Or is it better just to have it like that, technically? I don't know. I don't know. Maybe it's unnecessary to flatten it. I have no idea. But I think this is going to return 3. Honestly. I mean, I know it will return 3. I mean, well, 2 here, 3 here. Yeah. So maybe... Do we flatten it? Do we not? I think we have to flatten it. I'm going to flatten it. Actually, I'm going to make a flattened version of it. Flatten grid. we did this yesterday, so for x in grid, jeez, man, it's hard to do this, bro. Like, can you use iter tools? Ways to flatten the 2D list, Python. I for S. I for S in grid for I in S. Turn flatten grid. Oh shit. Let's just print actually. Print flatten grid. Let's take a look. Okay. So really to find the value, I mean technically we can just create some sort of hashy set, and then we can I in flatten grid, and we do hashy dot add I, then we can do, well, if I in hashy, oh shit, wait, what do we do? If I in hashy, then we know our duplicate is equal to I. Alright, we can get a duplicate is equal to 0, and our missing is equal to 0. Create a hashy for I and flatten grid. Now we can do, well, we can take the length of this flatten grid. Say, well, the length is equal to flatten grid. Find flatten grid. Find hashy. We'd obviously you'd want to do, well, duplicate dot add. Sorry, my bad. Hashy dot add I. Now we need to find then we go to changes for I in range length, range length. If I how can we do this? I mean, bro, there's a way faster way to do this for sure. Like, I mean, matrix array. I mean, I know we can add this to a hash map and just find the missing one. I mean, technically we don't even need a hashy, bro. Honestly, like we can use a dictionary. Like it's just unnecessary. We can just go, well, minus go dick flatten map I. If flatten map, flatten grid I in my dictionary, then we can add it by 1, right? But if not, we can just add 1. Let's go dict flatten map I for 1. Otherwise, we can just check, well, another for loop for I in range length. If flatten, sorry, if minus go dict flatten map I equal to yeah, let's get rid of this. Let's print our dictionary just to make sure, see what we're seeing. Expected an indent. What the? Expected an indent, dude. What the hell are you talking about? What was wrong with this, bro? Oh shit. Length. Oh, jeez. I'll be back in a second. Parents calling. Jeez. Yo, what up, guys? Sorry, back again. Had to get my Ubisoft account linked to a phone number, so we're back. But yeah. Let's. I think I realized where it was while I was on the phone, so I think we just have this messed up here. I don't understand why this is not running. Expected an indent and block after function on line 60. Bro, what is going on here? Like, indentation error, dude. Like, what? Oh my gosh, dude, that's why. Didn't think about that one. Okay, there we go. Okay, so we got our map here, right? Well, pretty much, I think we can just hard code. No. Well, if minus go dict flatten grid I is equal to 2, then we just and we know, well, duplicate is equal to 0. Duplicate is equal to grid I, right? So that we know our duplicate. Now I think to find the other one, we got to loop through. Well, for I, for key value in my dictionary dot items, we can check, well, if key let's just check our values, right? Do for key in minus go dict, right? Can we do it like this? If I underscore dictionary, then our missing is equal to my missing is just be equal to I, right? I don't think that's gonna work, but let's just take a look. We'll return our, what is first? Our duplicate. Return our duplicate and our missing. Oh, we declare our missing over here. Missing is 0. Enumerate. Is this the way you do it, bro? I don't know. I've never really used enumerate. Maybe this is the case where you need to use it. Like, let's just print I to each time if I'm curious what I'm looking at. 0, 1, 2. How's it 2, bro? What? What 3, 4, 6? How is it 2 here, bro? What the hell? Somehow we need to add. It's definitely a much better way to do this, bro. I mean, do the no way. I need this much code. I key and enumerate my dict keys. Let's print out key, dude. I'm curious to see what our key is saying. I mean, really, our edge case is going to be, well... Dude, this is so stupid, but I'm going to do it anyway. If missing is equal to 0, after all this, then we do missing is equal to the length of... Bro, this is like the worst code ever, like... Oh my god, I'm thinking Java, dude, Jesus. Oh, bro. No Java, bro. Let's not find a duplicate here properly. print out duplicate really quick. Why is 2 here, bro? Like, bro, I've been doing this problem forever, bro. Oh my god, dude. Okay, in my dictionary, plus I equal 1 for my dictionary. My dick. Grid I. Let's see what are we getting here, bro? Got a double. Okay, bro, this is so confusing. Okay, print flatten grid I. Okay, bro, how is it getting 2, dude? It's getting 9, 9. There's no 2, bro. Like, what? If flatten grid I in my dictionary plus equal 1, then we check. Well, if my maybe we don't even need this, bro. We can just, well, we just know. If it already is in the dictionary. Then this is the missing number. Bro, how are we returning 0, bro? Like, what the f is going on here? Why are we returning 0, dude? Like, what, bro? I don't know. Bro, why isn't this running for iron range length? Maybe we're not adding this properly, I think. If -score dictionary. I'm gonna try to flip it around, bro. I don't think this is gonna work, but it's like, dude, this is insane. Am I getting 0 from missing always? Duplicate is never assigned. Oh my god, dude, what the? Bro, what? Wrong handling of duplicates. Duplicate is never assigned. Bro, was that my whole issue the entire time, dude? Like, what? How are we getting 1, bro? Like, what? We're assigning the value here. That's why we need to assign the key. Red eye. Oh my god, dude. Let's see. I don't think this will submit, but shit, man, we were so close. Bro, how's the missing number 4 here, bro? Like, what? How is this the missing number, bro? Like, three. How is the missing number here 4, bro? Like, what? We have a 4. Like... Dude, this is insane that this problem is taking me this long. We need to change this. We need to go in the range of 1 to length plus 1. Then we check, well, if I not in my dictionary, then that's our missing number. Our missing value is equal to I. I guess we can just break. This stops. We don't need this edge case now because we can just loop from 1 to n. This should return the correct value, I think. L 1, bro. There we go. Okay. What did they do here? They did n is equal to length grid. Curve is equal to n times n times n times n plus 1 divided by n. What is going on here, bro? Yeah, this is the solution I did. Interesting. Okay, nice. That problem took a little bit longer than I thought, but that's okay. We got it. At the end of the day, we solved it. Let's take a look at some binary trees. See what we got going on today. Construct a binary tree from pre-order traversal. Array image is pre-order, where it says pre-order VSC binary search. You conduct a tree and return its root. Such tree with the given requirement for the given test cases. Guarantee that there is always one. Root returning. Okay, so pre-order traversal. I have to print this on my wall, bro, still. I always keep forgetting. What is a pre-order? The root node of subtree is visited first, then the left subtree is traversed, at last the right subtree is traversed. Okay. Let's do a pre-order traversal. We'll do def DFS, passing out root. Alright, we'll create like a res array of some sort, right? Here. Then we'll pass in I'm gonna call the DFS function on our root here. Passing out node, then we can do, well, if not node, we just return, right? Otherwise, we trying to think here. Fuck. We want to check out, go left side first. So I guess if node.left is not none, then we want to do well, DFS. Node.left. Then we want to do our node.right. Passing out DFS node.right. Passing out DFS function. Get rid of this crap. Result append node.val. I don't know if this will work, bro. I don't think so. Root is not defined. Oh, we got. Oh my gosh. Oh. We're given a list. Oh. Okay. Oh my gosh, dude. Well, never mind. I thought we were given the tree. No, okay, so we're given this, so then we're gonna need to go, this is the root, left, 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 and right. How are we gonna know? I guess we must have to save the, we have to save this value, and we keep going, right? Until we reach a value that, like this 10 here, until we reach this value. Once we reach this value, then we know we go over the rest to the right. But somehow, how are we gonna have to do that? So I think we're gonna have to save our root, right? Because our root is equal to the pre-order of 0, right? We're gonna loop through, well, while let's do a for loop. We'll do for I in range length pre-order, right? And we'll do, well, we'll check. We'll do, well, while pre-order I is less than root, then we'll append everything. So then we'll do, well, we need to start from 1 though. 1 to the length. We don't want to pass in the root. We check while this, then we just append. We need to add like a, let's make our previous val equal to root in this case, right? And we pass in while this is less than root, then we check, well, previous val is less than if previous val is less than we want this to be equal. Shit. We need to do, well, if pre-order previous val, it was stunning for me, previous val is less than root, sorry, is less than pre-order I. So if it's less than the number that we're looking at, so if we're here, we're comparing, well, okay, it's less, then we're doing, well, is previous val less than pre-order I? Is previous val less than pre-order I? If it is, then we want to move to the next value, right? No. Shit. Oh, man, I'm getting confused. The previous val is currently at 0, right? So we're checking here. So we're checking the root. Is technically this number here less than the current number there? Then we do shit, bro. We're gonna have to make our tree node and everything. Shit. Tree node. Well. Is equal to tree node root then code left is equal to pre-order I. Oh shit, let me check, well, if pre-order previous val I is less than pre-order previous val, then we want to append to the left. Otherwise, we want to append to the right. Else pre-order else we want to code right is equal to pre-order I. Okay. And we want to increment I plus or equal 1. I plus or equal 1. And we want to increment, well, previous val 2. Val plus or equal 1. Previous val plus or equal 1. Oh my gosh, this is where it went, dude. return cur. While it's less than root, then what happens if it's not less than root? Then we're not really doing anything. Do we have to do another while loop? Do the same thing? While pre-order I is greater than root, then we want to do the same thing, right? Man, my solution is so bad. There's definitely a better one. Like, let's do like. We return dummy. Is that how it works, bro? I don't know. This is definitely some sort of syntax error here for sure. Like, I'm curious. Corrected approach using recursion. Oh my god. Really? Yeah, well, I didn't. Root is just a value, not a tree node. Root is equal to pre-node, pre-order 0 stores an integer, not a tree node instance. That's where I create the tree node instance here.
So you better get ready.
Okay. Well, didn't go very well. While pre-order root loop doesn't work because root is never updated after the first iteration, the logic to place the node is incorrect. User. It's just a hard problem, bro. Just recursion enough for this. Okay, might as well just restart. I mean, my logic's wrong, so. So we want to pass in our root, right? It just needs to go after, right? Got our root here. Val and pre-order one to the end. I believe we're slicing here. Right. Then our val is node is equal to tree node val. If val is less than stack minus 1 dot val. Okay. Checking left here, I think. I mean, we have similar logic. It's just this is definitely a better way to do it. Is less than the top of the stack. So our root is less than stack minus 1 dot val. Then stack minus 1 dot left is equal to node. Else, if it's not, then we know it's a right node checking right, I think, right? Else. So then our parent equal to none. I don't know why we're doing this. While there's something in the stack and stack minus 1 dot val is less than the current value. Okay. While stack is at the top of our stack. And val is greater than the top of our stack. Stack minus 1 dot val. While stack and val is greater than top of our stack, then we want to assign well our parent is equal to stack dot pop, right? And we want our parent dot right is equal to node. So this is an interesting way to think about it here. So what we're doing is we're looping through using slicing. So we're starting from the first value because we implemented our root, right? We make our node is equal to tree node val. We check the left. Well, if the value is less than the top of the stack, then we append to the left, right? This holds a reference to our root value technically. Then when we get to the right, we create a parent array, value to, you know, store the tree node. And then we check, well, while the stack has something in it and the value is greater than the top of the stack, then we append our parent to the root, so then we can pop. So that parent.write is equal to node. And then we append this one to the stack. Because we need to keep track of the parent when we're going right, I think. Oh, wait. No, wait. Hang on. No, I'm tripping. Hang on. So we got our node here. We check if it's left, right? So we go left. Every time we go left, we just append. But if we go right, I think we go left, right? We append here. Or we keep the root at the parent, right? Because technically, if anything's greater than the parent, we gotta go left. So then, root of code. This test case. Update the stack. Oh, okay, we stacked it up in the node. Okay. That's what I was missing. We have val1. We have val1 is less than the top of our stack, so we go 5. Right? Okay, 1 is the left child of 5 is the stack. Last one is equal to left. 8, 5, 1. Okay. Then we get 7. Well, 7 is greater than that, so we pop 1 from the stack. Pop 1 from the stack. And val 7 is still greater than 5, so then we pop that, and we pop 5, so we got 8. So then we got 8. Now 7 is a right child of 5 because 8's not greater. So then we push there, and then we go to the next value, then we get 10. We check 7, well it's greater, then we pop, and we got 8, then we pop again, we go to 10. Okay. There's a right child of 8. And we have 12. Right child 10. Okay. It's an interesting way to think about it, man. I don't understand how people think about these, bro. I understand, but it's... Yeah. I'm not returning here. We return. We return the. What are we returning? The root node. Return root. Did you mean tree node? Yes, I did mean tree node. Thank you. What's that? What's up? Nice. Alright, we're gonna continue through some trees. I'm surprised that was that high. That was a tough problem, I thought. kind of want to do an easier one. Maybe we can do like hash 2 binary trees. Yeah, fuck it. Should we check it out? What are we returning? Okay, we all work with tree nodes the whole time. Okay. Imagine that when you put one of them to cover something. I am so confused. Bro, this makes it so much harder, like. That's what I was thinking. This is a lot harder because you have to think about the merging. You have to think about adding the values. I think this is a problem for another day. Let's... Diameter of a binary tree. Let's check out this one. Okay, given the root of a binary tree, return the length of the diameter. Diameter of a binary tree is the length of the longest path between any two nodes in a tree. This path may be or may not pass through the root. The length of the path is represented by the number of edges between them. 4, 2. We've done this one, bro. 5, 2, 1, 3. Yeah, bro. I've definitely done this one before. I remember doing this one. We've done this one, bro. There's a similar question to this, like, that I've completed before. For some reason, dude, I know I've done this one, bro. And I know this is a recursive function, like... How did we do it? I remember watching a Leetcode video too, I think, doing this one. This is a tough problem, bro, like... Yes, bro. I know we watched it. Root BST return the minimum difference between the values of any two different nodes in the tree. The minimum difference. This is a binary tree. Okay. I think this is a little easier. I think I did this the other day too, didn't I? Yeah. Did we do this yesterday, bro? I swear to God we did this one yesterday. How can we solve this? Jeez, I don't remember the other one at all. Like, minimum difference. So, I mean, we're only gonna have to go left because that's gonna be the minimum difference. Oh, well, actually, not necessarily. Actually, that's not true. I feel like the root could be 47, and you could have 48 of the on the right. So. Man, I don't know. This is tough. This is a tough problem, bro. I'm gonna ask for a hint, man, because I really don't know, bro. I don't know how to approach this. Like, distance between BST nodes. Give me a hint. No code. Let's take a look. Think about in-order traversal of the BST. What property does it have? How can you use it to find the minimum difference? In-order traversal, dude. Jesus. Travels left, root, right. We start all the way from the end. In our Russia, since it gives a sorted sequence, the smallest difference will always be between the two consecutive values in the sequence. Okay. We'll be back, 1 second. Came back, had another call, and I'm getting called a lot. Okay. Check the minimum difference between these BSTs. So it looks like here that we need to keep track. Check the previous node. So would we traverse all the way down to this node and then start from here? I don't know. Okay. I'm gonna pass in root right. Wait, how does it? You know, want to go root left right? No, left root right. Okay, left root right. So we pass in root dot left. I don't know how to do this traversal using a stack. How do we think about it using a stack? We'd append append we do an iterative pre-order traversal. Okay, we want to stack node is equal to stack.pop. Then we want to if node.write we stack.append node.write node.left stack.append node.left. The reason is we're doing this is because we want left to be processed first. So we do our left node. Man, is it pre-order traversal, man? This stuff is so confusing. Don't know how to think about this problem, bro. Select somewhere the in-order traversal. We keep a pointer to our current, which is our root. Our previous is none. Current, right? So we want to keep all our current. equal to root. Previous is equal to none. Then we need our absolute min difference. Min diff is equal to float infinity. While stack or current node is equal to stack.pop. Okay. Traverse to the leftmost node. We have to get there. Okay. While stack or current, right? We have to get to the leftmost node. Get to the leftmost node. Right, so we would do while current is equal to current.left, right? Stack.hinge current. Okay, alright. All the way to that number, right? We got all the way left. Okay, so we're all the way left. So what are we doing here? Right? Deals with the null value. Our current dot left is null. Then it stops. Because we're last in, first out. We can process current dot pop. Sorry, node is equal to current dot pop. Process node. Right? Okay. This is not the first node. Calculate the difference. If prev is not none. Not none. Then min diff is equal to the min of min diff, and then current minus previous. Need the dot out.
Men's tennis recreating each other's celebrations.
After clinching, this is Patrick.
Men's tennis recreating each other's celebrations.
After clinching, this is Patrick. After his win, he went like this to turn up the volume. Like this?
Men's tennis recreating each other's celebrations.
After clinch.
Asking men's tennis helmet.
What do we want to do here? We want to return the min difference. Say capital D. Drive as attribute plot. We need to somehow check for man, come on. Prev is equal to current is equal to has no attribute popped, dude. What the? Current left current. Oh my god, dude. I'm not referring to the stack, bro. Jeez. Bro, did I actually mess up? Non-type has no attribute, right? It's no attribute, right? I don't know. Bro, we're processing the node here. Node.val, previous is equal to current. This is node.write. What is that current referring to? Bro, how did I get everything wrong in this, bro? Oh my gosh, dude. Okay. We have our current, we got our previous, we got our stack, we have our min difference, right? While our stack has something in it, or the current has something, right? So that's how we avoid the null type here, right? Then we return, well, while current, we boom, 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 down here to 1. Current is equal to current left, right? Process it out. Node is equal to stack.pop. Let's print current each time because I'm curious. I want to kind of visualize it. Tree node 2. L2 tree. Tree node 1. Left none, right none. None, none, none. I want to print the stack here, though. Jesus. You can't even visualize the stack, bro. Like, well, I know we pop this value, right? So we pop this value, and then we check, well, if the previous is not none, the previous is none. So then we make the previous equal to the node. So previous is here, and then current is equal to node.write. need sunlight, bro. Oh, man. This is so tough, bro. Like, literally so tough. Start with 4. The first element of the list is 4, so the root of the tree is 4. Okay, yeah. Man, I swear to God, this shit is so stupid. Like, preferably equal to 1. Move to the right chart current. Oh, that current, what current? Okay, now I understand what this current is doing. This current is going back up here because while we have current is not true, we append, and then current is equal to current not left. This is like such an easy solution, bro, like looking at this, but it's like so tough to think about. Like, I swear to God, bro, like, alright, we've been going for a little while. I got kind of destroyed on that question, so let's take a look at blind 75, dude. We'll do can't place flowers. I mean, along flower bed in which some of the plots are planted and some are not. However, flowers cannot be planted in adjacent plots. Give an integer array flower bed containing zeros and ones, where 0 means empty and 1 means not empty, and integer and return. Really, bro? Is this it? What do we do? for I in range length file bed. Make like make it count. Okay. File bed. We do well if file bed if file bed I is equal to 1. I is equal to 0. And file bed I minus 1 is equal to 0. And file bed I plus 1 is equal to 0. Then we can decrease n is equal to minus 1. Turn true if n is equal to 0, else false. I wonder if this will work. I mean, this is the first thing that came in my head, just to check all the adjacent and the one above it. We're gonna get some out of bounds exception right here, actually. Oh. Maybe not, because there's no statement. I should submit. Balling so hard, I need a slam dunk again. Bro, what? Put 1 here. How the fuck do we get 2? Oh shit. We need to replace it. Okay, well then file bed I is equal to file bed I is equal to 1. Okay, so now we got some edge cases, so I guess the edge cases would be, well, if file bed else file bed I is equal to 0. And file bed I is equal to 0. And file bed I plus 1 is equal to 0. Then we want to do this as well. else if I is equal to the length of flower bed minus 1 is equal to 0, then flower bed I is equal to 1 and minus equal to 1. Bro, there's no way this index is out of range. Bro, there's gotta be an easier way to do this. Sorry. I'm very greedy. 28.8%. What if we change this to old ifs, bro? Okay, screw this, bro. Okay, we're not gonna do this in one loop. Let's print out flowers. Print out flower bed. Okay, we print out flower bed. Bro, I wish there was more test cases than this, bro. Like, so stupid. Like, you return true if n is equal to 0, right? So then we maybe want to loop through it again for I in range, length, flower bed. Okay. Let's just check the. Also, flower bed I is equal to 0. And flower bed I. Flower bed I is equal to 0, and flower bed I is less than I minus 1. is. Oh, bro. Number flowers planted. Flower bed. +1 is greater than the length. Flower bed, dude. Oh my gosh, bro. Dude. Oh. Jesus, dude. This is insane, bro. This is insane. Like, bro. I think from memory I did this with 2 loops, bro, but I cannot remember. But I don't know if this will work. Flower bed I +1. Oh. Bro, this is insane. Like, this is literally insane. Like, I've been getting dirty money, Jordan Belford. Is it freaking 3 parentheses, dude? Like, Jesus, dude. Bro, what is going on here, dude? You're checking. You need to be careful with the boundaries. The first and last announcement. I did. Flower bed I is equal to 0. Left is empty. I is equal to 0. Flower bed I -1. Left is empty. I is equal to 0. Flower bed I -1. Such an interesting and better way to think about it, bro. Like, loop 2, we check well. Left empty, right empty, right? We check, well, if I is equal to 0, oh sorry, no, we have to do, well, if file bit I is equal to 0, right? We want to check left empty. So if the left is empty, it's, well, I is equal to 0. I is equal to 0. Or file bed I minus 1 is equal to 0. Right? So right empty is if I is equal to the length of flower bed minus 1, which is the last element, or flower bed I plus 1 is equal to 0. And what do we want to do? Oh, sorry, it's equal, yeah. If left empty and right empty, then n minus equal to 1, and then we plant the flower. So flower bed I is equal to 1. If n is equal to 0, we just want to return true. Otherwise, we get through this and we return false. What the fuck? Bro, did I do it again? Oh my god. Oh, bro, I'm so used to calling variables like this, dude. If n is equal to 0, we just return true. The amount of... Oh, bro, thank God. Okay. I mean, we thought about it the right way. We just could have executed it a little bit better. But hey, I'm going to call it there, man. Jeez, it's been a long day. Yeah, going to get into some other stuff now. Appreciate you guys watching. See you guys later. See you guys tomorrow.